Today we're covering 2-8 part 2. We're going to finish absolute value functions and inequalities. So we are going to write and solve absolute value equations and inequalities. We started looking at it last time, what it means to have the absolute value of x equals a value, absolute value of x is greater than, and the absolute value of x is less than. So we're going to actually solve some more complicated problems. So here's an equation. Solve the equation -3 plus k equals 10. So think about what this means. It means there's a value in here that's going to be equal to 10. And whatever k is, this value has to end up equaling either a positive 10 or a negative 10 for the absolute value to equal 10. So that's how we're going to set this problem up. So the rule is for the absolute value of x equals a, x has to be either negative a or positive a. And in this case, we want the value of this expression to equal either a positive 10 or a negative 10. So that's how we set it up as two equations, -3 plus k equals 10, or -3 plus k equals negative 10. Solve for k. So here we're going to add 3, and be careful. You like to do shortcuts, so a lot of times I'll see students add 3, this is 13, and then they'll give me the answer, positive 13, negative 13. And you'll see it doesn't really work that way. When we add 3 to this, we're going to end up with a negative 7. So our two solutions are k equals 13 and k equals negative 7. And if we were going to graph it, it would be graphed as, whoops, that's pretty ugly. It would be graphed as a number line with only 2 points at 13 and negative 7 filled in. All right, solve the equation. The absolute value of x over 4 equals negative 6, or minus negative 6 equals negative 2. So the first thing we need to do is get the absolute value function by itself, because that then, once we get the absolute value function by itself, then we can do this kind of, we can basically use this rule. So to do that, the first thing we'll do is add 6 to both sides. And we have the absolute value of x over 4 equals 4. So for this to be true, we know that that x over 4 is going to either equal to 4 or x over 4 is going to equal negative 4. So it's this whole expression that equals the positive or negative values. So set up those two equations, solve, multiply both sides by 4. And in this instance, you actually do get mirror images of each other. X is going to be 16 or negative 16. All right, here is one for you to try. See if you can do this and bring questions to class. Now we're going to look at inequalities that are a little more complicated because we have two possibilities, the absolute value being greater than or the absolute value being less than. So we can solve the absolute value inequalities using the same sort of methods that we just used for equations. Here are kind of the basic steps. First thing you want to do is isolate the absolute value expression. So that means whatever is in between the parallel or vertical bars. It doesn't matter how complicated that is, but you've got to get that by itself. And we saw that in the second example where I had to add 6 to get the absolute value expression by itself. So get that by itself. Then we're going to rewrite it as a compound inequality. Remember, if we are looking at a less than, it's going to be an and kind of compound inequality. If it's a greater than, it's going to be an or. And then we're going to solve each part of the compound inequality for x. And this is what I said. Absolute value less than, that means it's less than so many units from 0. So we're going to have 0 in the middle here, and we're going to have some interval around 0. That's our solution. If it's greater than, it means it's going to be greater than so many units, so it's going to be outside that interval, and it's going to be an or. Solve the inequality, graph the solution. So we're graphing on a number line. Negative 4q plus 2 is greater than or equal to 10. So it's a greater than, so it's going to be an or. Isolate the absolute value function. That's the first step. It's isolated. All we have on this side is the absolute value expression. And now we're going to set up our compound inequality. So it's going to be, and think about it. So what do we have? If we have 10, so this means this expression is going to be greater than 10 units away from 0. So if this were 0, it's got to be over here. So this is going to be, this part of the interval is going to be something greater than or equal to. And here, this part is going to be less than or equal to, right? Because if this is negative 10 and this is positive 10. So notice what happened here. We rewrote it as our disjunction because we know it's a greater than. So we have negative 4q plus 2 is greater than or equal to 10, or negative 4q plus 2 is less than or equal to negative 10. So we had to switch the direction of the inequality for the negative value because we're going in the opposite direction. And now we just solve. Subtract 2 from both sides. Divide by a negative 4. Remember, we're dividing by a negative number, so the inequality switches directions. And we end up with q has to be less than or equal to negative 2, or q is greater than 3. So this is our solution. Our graph of that solution looks like this. Less than or equal to negative 2, greater than or equal to 3. And to check, you can test a point in each region, each of the 3 regions. So if I picked at 0, plugged it in, negative 4 times 0 is 0, 2 plus 2. Is 2 greater than or equal to 10? It's not. And notice it's not part of the solution region. If I picked a point here or here and plugged it in, I should get a true inequality. So even if you don't do it for homework, on a test it's a good idea to check. Okay, solve the inequality, then graph the solution. So here we have one, again, it's a greater than, so it's going to be another or, a disjunction. But we need to solve it, we need to first isolate before we set up our compound inequality. So we're going to add 3 to both sides first, and now we can set up our compound inequality. It's going to be 0.5r is greater than 0, or 0.5r is less than, actually greater than or equal, less than or equal to, and negative 0 is basically 0. So we have this. So if we divide both sides by r, we get r is greater than or equal to 0, r is less than or equal to 0, r is greater than or equal to 0. That's basically the whole number line. So in this case, the solution is going to be all real numbers. And your number line would just be fully covered. So sometimes you get identities when we solve inequalities. All right, here is a greater than for you to solve. Try that and see how you do. Now we're going to get to less than. And remember, it's less than so many units from 0, so that means it's going to be, it's going to be an and conjunction. Other than that, we're going to solve it the same way. So isolate our absolute value function. Here's our absolute value function. So to isolate it, notice this is not part of the absolute value function. It doesn't have the vertical bars around it. So we need to get rid of this before we write our compound inequality. So I'm going to multiply both sides by 3. Now we do have this isolated, and we're going to write our compound inequality with and. So it's going to be 2x plus 7 is less than or equal to 3. And again, we flip the inequality sign when we're looking at the negative side. So it's going to be 2x plus 7 is greater than or equal to negative 3. Solve, subtract 7 from both sides, divide by 2. And we get x is less than or equal to negative 2 and greater than or equal to negative 5. So this is the solution. X is greater than or equal to -5 and less than or equal to 2. Number line looks like this. All right, let's try one more. Solve the compound inequality, graph the solution set. So this is a greater than again. So remember, greater than means we're going to do an or. So first thing we want to do is isolate our absolute value function. This is not inside, the -2 is not inside the absolute value vertical bars, so we're going to get rid of that by dividing both sides. Oops. Dividing both sides by -2. Notice, because I divided by a negative number, we changed the direction of the inequality. And now we set up our disjunction. X plus 5 is less than -5 and x plus 5 is greater than. So since this is negative, we're going to switch the inequality on the positive one. Solve for x. So subtract 5 from both sides. This gives us x is less than -10 and x is greater than 0. So we need to define the interval of what numbers satisfy both of these criteria. Which numbers are greater than 0 and less than -10 at the same time? No numbers. So this actually is a contradiction. No real numbers satisfy both of these conditions, so the solution set is the empty set. And you don't need a number line if there's no solutions. All right, so that wraps up this section 2-8. Here is homework. Bring any questions to class.